This is note-taking guide 5.3 for Math 2, and I'm going to show you how you can graph a parabola when it's in standard form. First of all, just remember what standard form is. It would be in this ax squared plus bx plus c form, where a is the number in front of the x squared term, b is the number in front of the x term, and c would be the constant number without a variable added or subtracted back behind. So in order to graph it in this form, the very first thing I'm going to do is find the axis of symmetry. There's a little formula here to find the axis of symmetry. It's called the opposite of b over 2a. So we're going to use that formula to find our x value of our axis of symmetry. After we find the x value, we know we have the x value of the vertex point, and we can substitute it back into our equation to find the y value of our vertex point. And then we're just going to follow a pattern of our parabola by looking at the number that's in front of our a term. If the number is 1, our pattern is 135. If the number is 2, we would times that pattern 135 by 2 to get 2, 6, and 10. So let me just get you started on this first example, and we can show you how it works. So we're going to graph the equation of the parabola in standard form, and it's x squared plus 4x minus 5. So the first thing I'm going to do is follow that formula, the opposite of b over 2a. The opposite of b would be negative 4, and then I'd have 2 times a, and my a value will be 1. So 2 times 1. So I really have negative 4 divided by 2, which would be a negative 2. This tells me the x value of my ordered pair that's my vertex point. To find my y value, I'm going to take that negative 2 and I'm going to substitute it back into this equation up here. So I'm going to go negative 2 squared plus 4 times negative 2 minus 5 and find that value. Negative 2 squared is 4. 4 times negative 2 is a negative 8, and then minus 5 from back behind. So I have 4 minus 8 minus 5, and that value is a negative 9. So this first example right here, my ordered pair is negative 2, negative 9 that I'm going to graph, which it looks like I kind of go off my graph here, but let's see where we're at. Negative 2, negative 9, so we're just going to call it down here in the middle of my other graph. I would be over 1, up 1, because the number in front of my a value was 1. So 6, this would be 7, 8, 9. So over 1, up 1 for my next ordered pair. And then from those ordered pairs, we're going to go over 1, up 3, which would be here and here. And from there, over 1, up 5. 1, 2, 3, 4, 5. So right here and right here. And we can just draw our parabola through those points that we just graphed to get a good sketch of where our parabola is. Alright, that next example is a 3x squared minus 12x plus 4. And again, I'm going to start with the same formula of the opposite of b over 2a. The opposite of b is a positive 12. And then 2 times a would be 2 times 3, which is 6. So I have 12 divided by 6, which is the number 2. So I'm going to substitute the number 2 back into my equation. I'm going to have 3 times 2 squared minus 12 times 2 plus 4. 2 squared is 4. 4 times 3 is 12. Negative 12 times 2 is a minus 24, and then I have plus 4. So I'm 12 minus 24 plus 4 for a starting point of negative 8. Again, I'm a little bit off my graph here. I'm over 2 and down 8 for my ordered pair. Over 2, down 8. So kind of here's 7. And then let's just go as far down as we can for 8. So we're starting here, and then we follow our pattern of our graph. Our normal pattern is 1, 3, 5, but we had that 3 out in front. So our new pattern is going to be 3, 6, and, I'm sorry, 3, 9, and 15, because I take that 3 and I multiply it through my pattern. So I start here and I go over 1 and up 3 in both directions. From there I go over 1 up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there and there. My graph got quite a bit skinnier when I did that. All right, 2 more examples. Here's my next one, the negative 2x squared plus 4x plus 2. We know that negative 2 is going to turn us upside down, so let's make sure we follow our pattern down instead of up, and let's just do our math. So the opposite of b over 2a. The opposite of b would be a negative 4, and then 2 times a is a negative 2. So on the top I have negative 4, on the bottom I have negative 4, which actually gives me a positive 1. So I'm going to substitute positive 1 into my equation over here to get my y value. So a negative 2 times 1 squared plus 4 times 1 plus 2. 1 squared is 1, and then times by the negative 2 out front is negative 2. 4 times 1 is 4, and then I just have that plus 2. So right here, a negative 2 plus 4 is 2, 2 plus 2 is 4, so my ordered pair is 1, comma, 4 for my starting point. I know I'm going upside down because of the negative out in front, and my pattern is normally 1, 3, 5, but I get to times my pattern by the number in front of the x squared term, which is up here as a negative 2. So my pattern's negative 2, negative 6, negative 10. So I go over 1, down 2, over 1, down 6 for my ordered pairs. And I just draw my graph through those ordered pairs just like so. Alright, one last example of the exact same thing. This time I'm missing a value though. Is it A, B, or C that I'm missing? A comes from the squared term, B comes from the x term, and C comes from the constant. So the constant's there and the A's there, so it's C that I'm missing. But the formula is the opposite of B over 2A, so let's just plug stuff in. The opposite of B, again I'm missing B, so it's going to be 0 over 2 times A is 2, but 0 over 2 is just going to be 0. So I'm substituting 0 into my equation, so I'd have 2 times 0 squared plus 4. That's going to be 0, so I'm left with just 0, 4 for my ordered pair. So over 0 up 4 for my starting point. My normal pattern is 1, 3, 5, but I get to times my pattern by this number 2 that's out front. So my pattern is 2, 6, 10. So from this spot I get to go over 1 up 2 in both directions. The next one would be over 1 up 6. My parabola goes through those ordered pairs. We're just going to sketch it best we can. And that's how we graph parabolas in standard form.